Here is a regular hexagon and a regular pentagon. Work out the size of the angle marked X. You must show all your working. So it's really important that you pay attention to what they've told you in the question. And they've told you that this is a regular hexagon and a regular pentagon. Okay, what does that mean? It means that all the sides on each of those respective shapes are equal and all the angles are equal. So what do we need to do in this question? Well, in this question, what we need to do is work out this angle here and this angle here. Why? Because if we know those two angles, we can add them together and subtract from 360 in order to work out X. So 360 would be my green full turn there. So I need to work out my red angle, my blue angle. I need to add them together and subtract from 360 to leave me with my angle X. So how do I work out the blue and red angles? Well, you either know your interior and exterior angles of regular polygons, in which case, great. But if you don't, you need to have a way of working them out. So these angles here, the one I've marked in blue and in red, are what we call the interior angles. In other words, the angles on the insides of these shapes, not the angles on the outsides of these shapes. So let me just show you some little diagrams of interior and exterior angles. I'll put this next to the pentagon here. So this is a pentagon here that I've just brought onto the screen, a regular pentagon, which is the same as this shape here with the red angle in it. And then this is a regular hexagon, which I've just brought onto the screen here, which is the blue angle, which is the shape with the blue angle in it. That's your regular hexagon. So how do we work out these angles? So obviously you can see on the diagrams I've just brought onto the screen, they've given you the interior and the exterior angles of these respective polygons. So here for the regular pentagon, the interior angle is 108 and the exterior angle is 72. For the regular hexagon, the interior angle is 120 and the exterior angle is 60. So that's great. I can see that therefore this interior angle here would be 108. And this interior angle here would be 120. And I can add those together and subtract from 360 to get my X. So I will do that in a second, but I just want to talk you through how you actually get these angles if you don't know them off by heart. So you may have in class done interior angles of polygons, and you may recall the method where you go from one vertex to each of the others. And this gives you the number of triangles in that shape. So you can see there's a triangle which contains 180, there is a triangle that contains 180, and just ignoring that 108 for a second, there is a triangle that is 180 as well. Similarly, over here, if you're not quite understanding just yet, bear with me, I will explain this a little bit further in a second. I'm going from one vertex, it doesn't matter which vertex you pick, I'm going to go from that one, and you go to each other vertex, and whoops, moving that one accidentally, and where's my line gone? You're splitting it into triangles from a single vertex. And that is a triangle that's 180, that's 180, that's 180, and that's 180. So that's the method for working out the interior angle. So 3 lots, 3 triangles is 3 lots of 180 for your pentagon, which gives you an interior sum of 540 degrees. So in this inside of this pentagon, there's 540 degrees. 3 lots of 180. Inside this hexagon, there are 4 lots of 180. Which is 720. So that is the interior sum. I'm just going to rub all this out so I can just see the wood for the trees here. So that's your way of finding the interior sum. But once you've got the interior sum, how do you actually use that? So I've got the interior sum here, which is 540. How do you actually use that to work out a single angle? Well, if all the angles are equal, because remember, it's regular, so if all angles are equal, I'm going to do 540 divided by 5, because they're all equal angles, because remember, it's regular. So 540 divided by 5 gives me 108, which is where you can see that labelled orange 108. Similarly, over here, I'm just going to jump down here, because I didn't have much room. I would do 720 divided by 6. Why? Because there's 6 equal interior angles, and you get 120, which is why you can see this 120 marked here. So that's if you want to work from the interior perspective. I'm now going to show you potentially a slightly easier way. It's entirely up to your preference. So that's the interior way of finding out the angles. I'm now going to talk you through the exterior way. So thinking about the outside. So in the case of the hexagon over here, the orange angles. And in the case of the pentagon over here, the green angles. So how can we use the exterior angle information to work out the interior? Well, it's just a single figure you need to remember every single time. So in this situation, the exterior angles on any polygon, exterior angles, these ones here, on any polygon, whether it's got 5 sides, i.e. a pentagon, whether it's got 6 sides, i.e. a hexagon, whether it's got 7, 8, 9, 20, 100, they always add up to 360. So all those green angles there, that one, that one, that one, that one, that one, if we cut them all out and put them together, they would give you 360. Same over here, if I cut all these orange ones out and put them all the way around together, it would give me 360. So this is the same for any polygon. Its exterior angles sum to 360 degrees. But again, because it's regular, because both of these are regular, I can just divide by the number of sides that we have. So here, divide by 5 to get me 72, which is why the green angle there is labelled 72. And over here, divide by 6, because I got 6 orange angles, which gives me 60, which is why you can see the orange angles labelled 60 there. Okay, how does that help us? Well, once we've got the exterior, we can work out the interior by just doing 180 degrees, take away that exterior. So once we've got the exterior, I do 180, take away 60, and it would leave me with my 120. Same over here. This is a straight line. Well, the one I've drawn is not so straight because I'm doing it freehand. But if you think about that purple as being a straight line, if you've worked out your 72 by using 360 divided by 5, then you're just going to do 180, take away 72 to leave you with your 108. So that's a quick guide to interior and exterior angles of polygons, and the fact that they're regular means you can just literally divide by the number of sides of each polygon respectively. So let's now actually do the problem itself. So we've worked out the interior angles of the hexagon and the pentagon respectively. So I'm going to add them together. So 120 plus 108. Because remember we're on a non-calc paper, so I'm going to add these together and I get 228. And then remember it's a full turn, so I'm going to do 360. Take away that 228 and I'm going to get 0 take away 8, which I can't do, borrow from there. (132 degrees). And always ask yourself, does it look reasonable? Go back to the angle. 132, is that reasonable for this? Yes, because it's an obtuse angle. It's 132 degrees. Well done if you watch that to the end.